All right. Today, good morning again. Y'all know that I'm Coach Dean, right?
Yeah.
All right. We're gonna do a little check on learning. We've been working with expressions, with order operations. Now we're gonna go into some little prior knowledge of we're gonna do distributed property, right? So we know that a constant. Somebody read what a constant is.
A fixed number whose value does not change. It's either positive or negative.
Okay, so in this problem right here, on this expression, we have two terms. This is the first term and this is the second term. According to our definition, which one of these is a constant out of 4x plus 2?
4 2.
2 is a fixed number whose value does not change. It's either positive or negative, right? So if we were to box this, we'll see that plus 2 or positive 2 is our constant, right? All right. You don't have to write it. I'm gonna give it to you. I'm gonna give it to you. So I'm gonna tell you when you need to write. But good job. Thank you for participating. Okay. Now, somebody raise their hand and let's.
The number multiplied by the variable is located in front of it.
Okay, we know that a variable is what? A letter, right?
Yes.
A letter. So, anytime we see a number that's right next to a letter, that means multiply, right? Just like our parentheses. That means multiplication. So, do we see a number that's in front of a variable or multiplied to a variable?
Yes.
What is that number? 4, right? So if we were to box this, we would say 4 is our coefficient because it's the number multiplied to the variable, correct? All right, good job. All right, we have the last one, which we already said, is a variable. Okay. Okay, now, same variable, same power. We know a variable is a letter, correct? That represents an unknown quantity. If you don't see a number in a power, it's understood to be 1, right? So, 3x and x have the same variable, and they raise to the same power. So these are like terms. Now, if I was to, let's say if I was to put a 2 right here, right? So that's 5 next to the same power.
Check the attendance, please, just so at this time.
Matter of fact, scratch that 5x. How about this one? 2x to the third power. Do I have any more like terms with 2x to the third power?
2 or 27 is x to the third power.
27x to the third power. Do I have any more?
2.7 to the
And that's 2 and 7/10.
No, 2 is x to the third power. All the third power.
X to the third power.
1 4 x to the third power. Negative 5.
X to the third power.
1 4 x to the third power.
1/4 x to the third power. Alright, now, these are like terms. And you see this box right here? None of these are like terms. Why? Because this one don't have a variable. This one doesn't have any x to the, they are not raised to the same power. Correct? And I'm going to give you this. Okay, now, what is an expression? So to be an expression, it got to have at least one.
Expression.
What somebody said?
There.
What it? Operation. So it got to have at least one operation, but it contains a variable, a constant, coefficient. It involves all these things, but it must have at least one operation. Could it have more than one?
Yeah.
Yes, but it must have one, right? All right. So we'll go to, all right. Well, left one out, but we're gonna go to our objective today. Now I want you to write your objectives down on the top of your paper. I will learn to generate equivalent expression using the distributed property. These are our objectives for today. Miss White. Get your head up. Write down your stuff. You have to go out and go call your mama. Write that under your bell ring. Put a line under your bell ring and write your objectives down. I'll continue to talk to you. Good job, my man. Way to work. Take dry reading. Oh, yeah, dry reading. Take it. Pass one to the groups. Okay. I want you guys to move. I want you guys to move to that dinner table. Let's go. Y'all have y'all mark. Get them mark. Get your stuff. Good job. Yeah. Huh? Okay. I changed it over there. All right, everybody reading the objective. We're gonna come back to this objective before the end of class. We're gonna come back to these objectives. All right, this is example 1. This is gonna be example 2. I want you to put it on your paper. This is example 1. Example 1. Next example 2. Right? Now, example 1, I'm going to rewrite it. Example 1. And then you have to tell me when you're ready to get started. Always put step and circle. This first step. Okay, now, when you have, I told you, in our bell ringer, right? When we have parentheses, and we have a number on the side of the parentheses, whether it's on the left side or whether it's on the right side, what operation does that mean? Multiplication, right? That's telling us we got to multiply. Now, hold on. Let's identify inside the parentheses. What do we call this X? This X called a variable. What is this 4 called? This positive 4 or plus 4?
Expression.
A constant, my man. We got a constant. This is a variable, and this is a constant. Are they like terms? No, because they got different names, right? If they have different names, they're not like terms. So we cannot combine this X and this 4, right? It's just X plus 4. We can't put them together and say 4X. That's not correct. They are not like terms. So that means that we got to multiply this 6 times the X, and then we got to multiply this 6 times the 4. Right? We got to do it twice. So what I do, I draw a line from the 6 to the X. So what is 6 times X? 6X. Now I'm going to change colors. Now, this is a plus sign, so I'm going to break it down. Now I got to multiply this 6 times the 4. What is 6 times 4? 24. Now, we know that 6 is called a coefficient, right? Because it's a number multiplied to the variable. This is our operation. Tells us we adding. And our 24 is a, start with a C. A constant, right? It is a constant. So 6 times X plus 24. It's a constant. No, you cannot combine it. This is a variable and this is a constant. You cannot, they are not like terms.
Then you gotta add it.
You cannot add it, they are not like terms.
You gotta multiply it.
You can't do anything.
That's your final answer.
Final answer. You cannot combine them, they are not like terms. This is a variable, this is a constant. It could be 2 steps or it could be more steps. And our problem today, this is the first step. There are only 2 steps, right? So let's look at problem number 2. Example number 2. And you're going to do some in your groups. But we're going to use showdown. Okay? This is 5. And this is step 1. X plus 7. Alright. Let's look inside our parentheses. Inside our parentheses, we got x plus 7. Can we combine them?
No.
Why not?
Because it's not.
They are not like terms. These x is called what? This 7 is called what? A constant. Right? So we got a variable and a constant. We cannot combine variables and constants. So what we got to do? We got to take this 5, which means what operation means outside the parentheses? Multiplication. That we got to multiply this 5 to this x. And we got to multiply this 5 to the 7. So what are we going to do? Draw an arc, right? 5 times x is 5x. Bring down my plus sign. Plus 35. Can we combine this?
No.
No. This is a variable. This is a constant. So we got to box it and say that's our answer. Final answer. Now, we're going to play a little game. We're going to play a little game called Showdown. I'm going to give you the rule before we get started. On this Showdown, I'm going to give you some time to think about the problem. You're going to think about it. Pay attention to me. Pay attention. We're going to do a showdown. Now, we're going to think about it. And once we get time to think about it, we're going to work the problem out. We're going to turn our paper on, right? Then I'm going to call a showdown, and you're going to talk to your groups. In your groups, you're going to speak in your groups, right? What answer you got? How do you get your answer? And when everybody get the same answer, y'all can turn your papers over. If somebody got a different answer, you're going to keep working, right? Until the time is up. So, next problem. Everybody put their pencils down. Pencils down. Pencils down. We're going to do this problem right here. That's number 1. We're going to do number 1 first. Put the pencil down. Pencil down. Think time. Think time. Think about how you're going to put the paint marker down. We're not working with the paint marker yet. Think about it. How you going to solve this problem? How you going to get your answer? Think about it. Right? What you going to do? You're going to look at your steps. Get your notes. Think about how you're going to solve this problem. Okay, think time is over. Now, you have 2 minutes. Begin. You work independent first. When you finish, turn your paper over. You already finished? Good job. You don't have to have a board right on your paper.
Board right now.
I just told you that. You're not writing on the board. Not yet.
I got that.
Okay, we'll turn your paper over. No, first. Oh, I can ask a question. Why y'all talking? Everybody finished? Okay, is everybody finished? Showdown. Explain it to your group. Show your answer too. Show your answer. Hey, Ms. Evans, she's not gonna work. Ms. Evans, she's not gonna work. She gotta get out of here. That's the option. Go ahead, you go take it to the office, call her mama, or do whatever. But she's not gonna work. She gotta get out of here. I asked 2 or 3 times. Take her outside. That's her choice. You gonna move to that next group, any third person.